morning, everybody. Good morning. Okay, so today we're starting chapter 3, which is called Real Numbers and the Pythagorean Theorem. And the first two sections of the chapter are called square roots and estimating square roots. Okay, so raise your hand if you've heard of square roots before. Okay, good. Okay, we're going to introduce them to you today, though, how they work and why we have them. Let's see, what do you hear in the word square root? What's the key word in there?
Oh, I didn't know.
Square. Okay. And root, but square, that's a key word. Okay. We're going to pass out these papers.
Yes, let's go over it now.
While I pass them out, have you guys seen these dot papers before?
Yes.
Okay. Okay, what you guys
Maybe he did.
what are some key properties? We have four sides, four equal sides. Okay, what else? What else do you guys know about squares? Christian?
They have four angles.
They have four right angles. Anything else? Yeah?
Sure.
Oh.
All the sides on it are like the four sides are parallel.
The four sides are parallel?
Yes.
Yes. Anything else? What about the area of a square? You guys know what the area of a square is? Christian?
If you have one side of a square, you multiply by 4, and then you get the area of the square.
Okay, so he says 4 times the side length will give us the area. Okay, are there any other ways to represent area? Emily? See you. Go ahead. Sorry? A power, so are you thinking something squared? Okay, what's being squared? Define the area. Brogan? The base number. Okay, so let's do, so he says, actually I'm going to write it on this paper down here. Alright, so we have a square. You guys said there's 4 equal sides. Okay, so what do you want to call this length? Not like, what do you want to call it? Let's give it a name. S? S for what? Side. Okay, so he says this is the side length. And then what did Emily say? You said it was something to a certain power. Something squared though, to the second power. Okay, so let's call that, let's say the area can be represented as side squared. Do you guys see that? Do you agree?
Yes.
Yeah? The area of a square can be something like one side length squared. Remember we just learned how about exponents last chapter? So you know what something squared means? Okay, and what else did we say we knew that? That a square has 4 equal sides. Okay, remember these things when you start this activity. I want you guys to find or draw an area. Draw a square with an area of 4 inches squared. Okay, just pretend each of these dots going from down, up and down and across are 1 inch. So I want you to draw an area that has, or square that has an area of 4 inches squared. And then I'll walk around and see how you do. Sorry? Yeah, and then prove to yourself and to me why that square has an area of 4 inches. So don't just, you have to come up with a square and be able to prove that it's 4 inches squared. You can talk with 2 neighbors. We need to get started. Okay, so why is that 4? Okay, let's see how many. So, okay, look up here real quick. So if I drew a square like this, how many square inches is that?
4.
So I have a 1 by 1. So what would the area of this be?
4.
1.
A 1 by 1. Who said 1? Yeah. Okay, so Christian has it correct. So if I wanted to draw something with 4 of these, right? What do you think I'm gonna do? This is a square area of equal, right? I said the square area of 4. Okay, look up here. Hey, up here. So, who wants to explain what a square with area of 4 square inches would look like, Jordan?
You would have to have like 2 of the lines.
Then you have 4 of these, right?
Yes.
So you said 1, 2, 3, 4. Okay, is this an area of 4 square inches?
Yes.
Okay, what is the side length?
2.
2, and what is this side length?
2.
2. So it is a square, right? All 4 sides are equal?
Side lengths have to be equal to
Side-
the number in the middle, or 4, or to your like area.
So side squared has to equal 4,
Yeah.
and we said that the side length was 2, and 2 squared is what?
4.
Okay, so let's write this down. So here is a square with area of 4. Okay, so we said that the side was equal to 2 inches, and the area is equal to 4 inches squared. Okay, now I want you guys to do a square that has an area of 9 inches squared. Okay, Mia, what am I going to do to create a square that has an area of 9 inches squared? What did you do?
I did 3.
Okay, so you did 9 little boxes and you put 3 across, right?
Yeah.
And then 3 down because they need to be equal length. So is this a square? It's a poorly drawn square. But this is a square that has 9 square inches in it, right? Okay, what is the side length?
3.
And what is this side length?
3.
Alright, so it is a square. So here's my square, 9 inches, with a side length of 3 inches, and the area is 9 inches squared. Okay, one more. I want you to do a square with an area of 16 square inches. Write on your paper, a square with an area of 16 inches squared. Okay, look up here. So what is this square going to look like? Christian.
So it's going to be like 4 squares on one side, and then 4 squares on the other side, 4 squares on the other side, 4 squares on the other side.
Okay, yep. I'm going to go 4. Yeah, 4 spaces down and 4 spaces across, and I'm going to get 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So does this square have an area of 16 inches squared?
Yes.
Okay, so let's put that one up. So we know the side is 4 inches, and the area,
16.
oh, yep. 9 inches,
16.
16 inches squared. Okay, one more. You have a question?
I have a comment.
Okay.
If you notice on the side of like, area equals 16 inches squared, you notice on the farthest right column, actually, is it like column? Okay, the column, you notice that it makes the multiples of 4.
Mm-hmm.
So, that's what I'm saying, that it gives you the answer.
So 4 times 4, right? These are multiples of 4 because we had 4 by 4. Just like here we had 3 by 3, so we have multiples of 3.
Yes,
And here we have 2 by 2, so we have multiples of 2.
yes.
Hey, that's good observation. Does everyone see what he saw?
Yes.
You understand what he saw? A little bit? Give me thumbs up if you understand. Thumbs down if you want to go over it again. area of 4 by 4, right? So we have 4 across and we're going 4 down. So if we're going 4 across and we're going by multiples of 4, we have 4, 8, 12, 16. You know those are multiples of 4, right? And then here we have 3, 6, 9 because it's a 3 by 3. And here's 2. So what do you think a 5 by 5 would be?
5.
What do you think that these squares would be over here? This would be
20.
3, 4, 5. This one would be
10, 13, 20, 25,
so did we go up by 5? So is this an area of
25.
25 inches squared? Yeah. All right. So I want you guys to find one more square. I want you to find a square that has an area of 8 inches squared. Remember what we know about squares. Okay, the key properties of squares. 4 equal sides. And in the area, which is side squared, needs to be 8 inches squared. Okay? Go ahead and get started. You can talk to your neighbors. Okay, so Jordan says it's not going to be a whole number.
Why a fraction?
Okay.
Because 2 times 2 is 4, 3 times 3 is 9, and there's no in-between numbers. So
You guys hear what she's saying?
4 and a half.
Okay. So let's look at this real quick. Okay, so here, let's say I'm making a square, and I'm just making a 2 by 2. So you guys remember these, right? Okay, so here is a square with an area of 1, 2, 3, 4. Okay, so we went 2 by 2. Okay, and like Jordan said, I need to find something. She said there's nothing between 2 and 3. So let's try and find one. So Isabella, we all trust Isabella, right? Yes. Okay, Isabella. So here I'm going down 2. What if I go diagonal? Am I going further? Okay, feel that tension. I want you to do that. Tell me if the length. Look up here. Is the length going further? Yeah. Do you guys agree, Isabella? Do you believe her? Okay, let's Grayson. I want you to take this across diagonal. Does it feel like it's going further? Yeah. Okay. So we've heard 2 people and me, 3. So 3 of us say, if I go diagonal, it's longer than if I just go down vertically. So what about something like this square? Is that still a square?
Yes.
Still a square? Okay. Okay, try and find a square that has an area of 8 inches squared. Okay, that was a hint. That was a hint.
No, it can't be a triangle.
Can't be a triangle, it has to be a square, all 4 sides equal. That's a hint of what the square is going to look like. All right, everyone, look up here. Look up here. A lot of you guys were doing this meeting and you figured it out on your own. Okay, back to your seats. Back to your seats. All right, everyone. Look up here. Who wants to explain to us why, draw us the square and then explain to us why the area is 8 inches squared.
Oh my gosh.
Okay.
Can you show it to us first? Because someone else showed it.
We'll go over it. Okay, Ariel, you want to put up here? I'm going to stand in front of the camera so you're not on camera.
You dropped something.
No.
Oh, you're sitting in front of the camera, so you don't see him?
Yeah.
I see. Just like a dark voice.
Okay, pay attention. Guys, look up here.
It's like,
I did that.
is that a kite? Oh, okay.
Okay, now show us. Why is that
Because
8 inches squared?
it's 1, 2, 3, 4. Although the corners are half of the square, so each one of these counts as 1.
Oh.
So that would be 5, 6, 7.
Yeah, thank you, Ariel. Thank you. Okay, sit down. Okay, everyone look up here. Do you see that? These are 4 whole, and then here we have a square, a regular square, but here it's broken up into like this.
So like a diamond?
Do you see that these ones right here are like this?
Oh.
But they create a whole square.
Yay.
So do you see that this is 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. And like Ariel said, they add up to 1. So here we have 4 whole squares. So that's 4 inches squared, and then we have plus 1, 2, 3, 4. So we have 8 inches squared. Yeah?
Yeah.
Yes?
Yes.
Okay. So here is my square. Okay, look up here. It's about to get even more real. Okay. So here. Okay, remember what Jordan said? She said it's like a decimal. It's between 2 and 3. It's not a whole number. Okay, I'm putting it right here, so this is a hint. So we know the area of this square that we just found is 8 inches squared. Okay, what do you think the side length is?
No, it's not 2.5.
Okay, let's do some guesses. Okay, someone said 3. What else?
Yeah, 3.
Someone said 2. What else? What do you think?
Someone's
Yeah,
4.
1/2? Okay.
No, I don't think that's right. But then-
Okay, any other guesses?
Somebody said 4.
2.5?
4.
4 and 1/2.
4?
Six.
Okay, you guys, first of all, here's the hint. Remember, it's probably between 2 and 3, right? We said that, Jordan said that earlier. So if we guess 4, 5, 6, probably not going to be correct, right? Joshua, what do you think?
1.5.
1.5? Okay, shh, look up here. Let's do some of these.
Oh, wait, no.
Okay, first of all, remember how this is 2?
Yeah.
Remember how we said this was 2? And that this, which is what our side length is more than 2?
Yeah.
Right? So it's probably not 2.
Yeah.
And it's probably not 3. So let's look at it another way. How do we get from 2 to 4? What did we do to 2?
Multiply this.
Or what else could we call that? Squaring it. So we squared 2 to get to 4. So we squared 3 to get to 9. And here we squared 4 to get to 16. So let's check some of these. What if we squared 3? What are we going to get to? 9. Okay, is that equal to 8? We're trying to get something equal to 8, right? Does that equal 8? No, so it's not 3. Okay, what if we squared 2? Is that equal to 8? No, so I don't think it's 2. What if we squared 1/2? You guys remember we did this last chapter?
Times.
Yeah.
Which would
It's
be-
1.
It would be 2
Yeah.
One
over
in,
2.
no,
which
it's
would be
1 over 4.
It
No,
would
1
be a
over
whole.
Why is it 1/4, Christian?
Because you always start with 1 if it's squared by fraction, and then 2 by 2.
Are you guys listening?
equals 4.
This was from your last chapter. Okay, say it again, Christian.
We have to start with 1 if you're squaring a fraction or going exponent for a fraction. And then you multiply the denominator by the exponent.
Okay, so he said numerator times numerator equals 1. Denominator times denominator, 4. Is 1/4 equal to 8? No, so I don't think it's 1/2. What about 2.5? Let's do 2.5 squared.
That's 6.25.
6.25. Is that equal to 8? Closer, right?
1.5.
It's closer. But that's not. Okay, what about 1.5? What's 1.5 squared?
You have a calculator over here.
2.25. Is 2.25 equal to 8? No.
Is it
Okay.
3.5?
Okay, so when we did 2.5 squared, we got really close. Okay, I want you guys to think about this. We did 2.5, got us to 6.25. And 3 squared got us to 9. Okay, do you have any more guesses?
2.7?
Mia?
3 and 1/2.
Okay, so we're trying to stay between 6.25 and 9, right? 8 is between these two.
sorry.
That's okay. Give us another guess. That's good though. Give us another guess.
2.6?
Mia.
Oh, me.
Yeah, give us another guess.
2 and 2.7.
Okay, she says 2.7.
That's
So let's do that.
7.29.
Okay, we get 2.7 squared is 7.29.
Can we do 2.9?
So we got close.
2.9, 2.9.
Okay, Jordan, what do you want to guess?
3.5.
What?
3.5.
3.5?
No.
2.9?
Okay, look back here.
Okay,
We've narrowed it down.
2.9.
2.9. Let's try 2.9. I got 8.41.
2.8.
So 2.9 squared is 8.41.
2.8.
7.84.
Okay, let's do 2.8.
7.84.
2.8 squared is 7.84.
Look up 3.0. I mean, 3. Wait.
2.85. 2.85.
Okay, 3 squared was 9.
2.85.
Elmo, what do you think?
9.5.
He says 2.85. Let's try 2.85 squared. We get 8.1125.
Oh.
So 2.85 squared. We are closer.
2.80.
It was 8.1225.
2.80.
We already tried 2.80, remember?
2.84.
2.84.
No, 2.83.
2.84?
Yeah. 2.83. 2.83.
2.84 squared is 8.056.
2.83. 2.83.
2.81 is 7.896.
2.83.
Okay, wait, pause. Pause. Hey guys, real quick. Look up here.
2.83.
So we know 2.81 squared is 7.8961. And 2.84 squared was 8.0656.
2.83.
2.83.
Raise your hands. Okay, so someone said 2.83 squared, 8.0089.
Oh.
Okay.
Can they do
Okay, I'm going to explain something to you.
2.8.
Aaron?
There's no way you can actually square it because it's on a Cuban square.
Okay, we're going to go off what Aaron said. We're going to go off of what Aaron said. Thank you, Aaron. Okay, so he said, he's noticing something. We keep adding decimals, and we're not getting to 8. We can keep adding. Let's do 2.82. Guys, shh, pay attention. So let's do 8, 3, 4, 5, 6, 8, 7 squared. 8.0347746. Okay. We're introducing to you guys something called irrational numbers. Okay, write this down in your notes. Write this down in your notes. Okay, you guys remember we have real numbers. Okay, real numbers are made up of 2 systems. We've got rational numbers and irrational numbers. We learned what rational numbers were last chapter. So who wants to remind me what rational means? Josh.
It can be turned into a fraction.
Yes. Yes, it can be turned into a fraction or decimal. Do you remember that?
Yes.
Do you remember that from last chapter? Rational numbers. What are some examples of rational numbers? Christian?
2.8.
2.8. Emily? 0.75. Jeremiah?
2.5.
2.5. What about 5?
Yes.
8.
Yes.
1/3.
Yes.
Okay, these are all rational numbers. Okay, now think back to your English class. We've got the prefix ear. What do you think ear, what does ear mean?
Not.
Elizabeth?
It's like it cannot.
Cannot. So, not, let's say that ear means not. So, not rational. What do you think not rational means, Emily? Not a ratio, so it cannot be turned into a fraction or decimal. Jonathan? Give us an example. Pi. Yes, pi. Do you guys remember pi?
Yes.
Pi, it looks like this. Pi is an irrational number.
It is. It's not even over.
What?
I think.
Okay, so pi is an irrational number. It can't be written as a fraction or decimal. So what we have found is another irrational number. Let's figure out how to write it. All right, so here we had 4 squared equals 16 inches squared, right?
Yeah.
What if I wrote the square root of 16 is equal to what? 4. So square root and squared. So something squared, let's just write that, and the square root of something, those are inverse operations. Do you guys remember inverse operations?
Yes.
So they undo each other.
Equal 1.
So the square root of 9 is equal to what? 3. The square root of 4 is equal to what? 2. So what do you think this one, what do you think the side length is going to be? So we did square root of 16, square root of 9, square root of 4. Jeremiah?
64.
Okay, look up here. Let's look at, it's okay, Jeremiah, look up here, it's okay. So you have square root of 4, we wrote, but that's really 2, so we wrote that equals 2. What if I didn't write this? These were the side lengths. Square root of 16, square root of 9, square root of 4. What do you think the side length would be for that one? Close. What do you think, Christian?
6.5.
6.5.
Wait.
Okay, look up here again. So I rewrote this side length as the square root of 16. So I rewrote this one as the square root of 9. I rewrote this side length as the square root of 4. How am I going to rewrite this side length right here? The square root of the area. So Jonathan? Square root of 8. Okay, now what do we notice about these numbers? 16, 9, 4. What are those numbers called? It's in your book. It's a vocab word. Rogan?
Potentially speaking is 8 squared as endless as pi. Why is pi more famous?
Because we use pi in a lot more applications. So circles, anytime you use a circle, you're using pi. So it's used more frequently.
Oh!
Where'd you find what? More applications you can. Yeah. Okay, so Josh, what do those numbers have in common?
They are. Wait. I have it. Okay, wait.
You want to consult with someone?
Yes. Okay, they're all perfect squares.
They're all perfect squares. Hey, perfect. Put this in your notes too. Perfect squares. So, perfect squares are numbers like 4, 9, 16, 25, 36, 49. Okay, do you know what I'm doing? Just integer squared, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, is 8 a perfect square?
No.
No, it is an irrational number. Square root of 8 cannot be written as a fraction or decimal. So just like with pi, when they have 3.14, and then I don't even know, it keeps going on forever, they didn't want to have to write that down every time. So let's do that in our calculator. Let's just look at what square root of 8 is approximated to be. So square root of 8 is approximately, do you know that sign? Approximately?
Yes.
Okay, so it's not equal, but it's close to 2.828427125, and it's going to keep going. Okay, so we don't want to have to write this down every time we want to use something like the square root of 8. So just like with pi, they didn't want to write 3.1425, whatever it is. So they created a symbol that they could use to write down pi. So the square root, they created a symbol that we could write. So square root of 8 is something like this, but they didn't want to write that down. So they created a symbol. So with ones like these though, 16, 9, 4, they're perfect squares. So we don't have to leave that. We don't have to leave it as square root of 9. It can actually be evaluated to what? 3. What does this evaluate to? 4. What does this evaluate to?
Two.
2.
So approximately 3.
Sorry?
So it's approximately 3.
What is approximately 3?
So
All right, so we're gonna go into estimating square roots in a second, okay? So make sure you kind of understand. Can I get a thumbs up if you understand what we've done so far? And a thumbs down if you'd like to go over more examples in between. Okay. Okay, let's look up here. Okay, so we don't want to write down this, right? The whole point of finding square roots is, I saw someone doing this, and I said, find the square root of 85, or 81. Let's do it, perfect square, 81. Do you want to draw out 81 squares and then find the side length? No. So the whole point of square roots is to make that a little bit easier. To find, I should know, square root of 81 is 9. So perfect squares, we're going to memorize these. You should be able to recognize them just like that. Okay, so let's make a number line. So here we've got